Hello students, welcome to the class of Software Engineering. In today's video session, let us discuss about the software requirements document. So as I told that the first stage in your software development lifecycle is to collect the requirements and analyze it. So all those requirements are later put into a document, and that document itself is called software requirements document, or it's also called as software requirements specification, or in short SRS, software requirements specification. So this is very important part of your project. So first you have to build the SRS, and then you can go for the designing and implementation phase. So the software requirements document mainly contains what? The requirements list. So it is an official statement of what the system developers should implement. So it mainly tells about what the software developers should implement. It should include both the user requirements for a system and a detailed specification of the system requirements. So mainly the SRS specifies all the requirements. So these requirements tell what type of system should be developed. So this helps the developers to get an idea what system they have to develop and how can they go forward in developing it. And also it includes the user requirements specified by the user. Those are called user requirements. And also it includes system requirements. System requirements are detailed specification of the system. Okay, so your SRS mainly tells the developers what should be implemented. So what features should your system have? So this document anyways contains the requirements details. So it can have user requirements there or system requirements. The requirements document has a diverse set of users. So this document can be used by several people. So who are they? Who are the users? Ranging from the senior management of the organization, okay, that is paying for the system, to the engineers responsible for developing the software. So here the users of this SRS range from the senior position, whoever are there, from there till the engineer who is going to develop the system. Okay, so there are n number of people using this document. Okay, so we'll see that. Users of requirements document. So first user is system customers. So here the customers, they actually specify the requirements. Okay, so those requirements will be listed and it will be clearly put into this SRS in a structured way. Okay, so now the customers will read their requirements. Okay, they really read it whether those requirements have met or not. Okay, and they will see how the requirement has been specified. If any changes need to be made, they can specify the changes there in the requirements. Okay, that is the first user, customer. Second user of this requirements document can be managers. So you know that it is the manager who is responsible for the entire project to be planned. So he will be actually telling how you have to develop the software. In the sense how to carry out that process. So from the beginning till end, it is his responsibility. So he has to see how the work has been done. So starting from requirements collection, then designing, implementation, testing, all those he needs to monitor. His role is. So what does he do? So he will get this requirements document, doesn't it? Once he gets this requirements document, he can actually, how he does the planning, mainly I can tell is based on this requirements document. So he will read all the requirements and he will start to plan which needs to be implemented first, how the development process should be started. So based on this requirements document only, because this document is only designed for how the product should be, correct? What it should, what features it should be. So he will read that one and he will start from that only. Next, system engineers use the requirements to understand what system is to be developed. So system engineers will be actually it's nothing but your software developers. So they will read this, keep on reading this requirements document in order to understand what system should be implemented, so that they will get an idea and they can start developing it. Okay. Next. System test engineers. Why are these test engineers required for testing purpose? Use the requirements to develop validation test for the system. So they have this requirements document. So they will start testing the uh, they will do the testing process based on those requirements. They can build the test cases. So if they have to do validation, they need to see that validation test means they need to see that each requirement is satisfied or not. So based on that, he can develop the validation test. System maintenance engineers. Now testing is over. System maintenance engineers, they have to maintain the system. Your system has been developed. Now next step is to, you have to maintain the system. So use the requirements to understand the system. So you need to use the requirements here to understand the system, because it's new to them, because they don't have an idea about the system. So they have to understand the background of the system. So they have to read, only one option is the SRS. So they have to use the requirements to understand the system and the relationships between its parts. So they have to read this requirements document in order to understand the complete system and what is the relationship between the system and its parts. Okay. So these are the users of requirements document. Users of requirements document. Next, we'll see the structure of requirements document. How the requirements document should be. So this is an IEEE standard. So you have to follow this standard only. So you all need to focus on this one, because you have to build an SRS for your project. Any project you do, you need to build the SRS. It is compulsory. So focus on this one. This structure is given by the IEEE standard. So it has different chapters. We'll see one by one. We have the preface. Preface. See, preface means what? I hope you have seen the textbook. I think first pages you have seen of a textbook. Their preface is there. This should define the expected readership of the document. So, who is actually need to specify who exactly are the users who are going to use this. So, suppose you have done a product, you think, or a project. So, this project is actually useful in some particular area. So, for some people, so that expected readership you have to define for who. Like if you have software engineering, this is defined for the software engineering courses, no? So you have to specify that one, why this book has been written, like that. So the preface, this should define the expected readership of the document. Next is the introduction. So this should describe the need for the system. Means why this system is required. What is the need for this system? and then it should briefly describe the system's functions. So later in the introduction part only you should specify the functionalities of the system, what the system will provide, and explain how it will work with other systems. So also you need to explain how it is going to work with other systems. Next chapter is glossary. So this should define the technical terms. If you are using any technical terms in your document, that needs to be defined in the glossary chapter. Next chapter is user requirements definition. So here you have to specify the requirements, or you need to describe the services provided for the user. So what services your system will provide for the user, that you need to specify. The non-functional system requirements should also be described in this section. You can include the non-functional requirements also. Next, system architecture. So this chapter should present a high-level overview of the anticipated system architecture, showing the distribution of functions across system modules. So here you should show the architecture of your system. So you have to build an architecture for your system. You have to show how all the different components are designed in the architecture. Next, system requirement specification. This should describe the functional and non-functional requirements in more detail. So under the system requirement specification, one should explain both functional and non-functional requirements in more detail. Next, system models. So here you have built an architecture for your system. Now next, system models means you have to include all the graphical models. Graphical models, that is using UML, you have to build the graphical system models. Next chapter is system evolution. So this should describe the fundamental assumptions on which the system is based. So you need to explain the fundamental assumptions on which the system is based, and if at all any changes you can make for the system, that you can specify due to the changing user needs or due to the hardware evolution. You can specify what changes you can do for your system. Next chapter is appendices. So these should provide detailed specific information that is related to the application being developed. So they should provide very detailed specific information related to your application. Example like hardware and database descriptions. Last chapter is the index. So several indexes to the document you can include here, like index of figure, all those. So these are the different chapters you need to specify in your SRS. So this is actually one of the IEEE standard way of representing a SRS. Next, we'll see requirement specification. Requirement specification. So already we have discussed about requirement specification. You are specifying all the requirements. So it can be user requirements, system requirements. Requirement specification is the process of writing down the user and system requirements in a requirements document. So it is the process of writing the user and system requirements in a requirements document. So what is this user requirements? The user requirements for a system should describe the functional and non-functional requirements. So the user requirements should describe the functional and the non-functional requirements. What is this functional requirements? Which mainly tell what your system should do. And non-functional requirements is related to the quality attribute of your system. System requirements, now this is user requirements, so they can include functional and non-functional requirements. What about system requirements? They are expanded versions of the user requirements. So it's just a detailed description of your user requirement. So these are used by the software engineers as the starting point for the system design. So system requirements are detailed specification of the requirements again. So these will be used by the software engineers as the starting point for their system design. So we can see the different ways of writing a system requirement. How to write a system requirement. So there are different ways of writing a system requirement. First one is natural language sentences. So natural language sentences. The requirements are written using numbered sentences. You're putting numbering for it in natural language. So how you are writing the requirements in natural language only with numbering. So each sentence should express one requirement. So each sentence will tell one requirement. This is natural language sentences. Next, structured natural language. Structured natural language. So here the requirements are written in natural language only. So structured natural language. Here the requirements are written in natural language but in standard form. Some standard template is being followed. Each field provides information about an aspect of the requirement. Next, design description languages. This approach uses a language like we can tell a programming language but with more abstract features to specify the requirements by defining an operational model of the system. So this approach is now rarely used, although it can be useful for interface specifications. Design description language, called as DDL. Next, graphical notation. So here you are using some graphical models. So supplemented by test annotations are used to define the functional requirements for the system. So you can describe the functional requirements using these graphical models. So you also have the UML use case and sequence diagrams. These are commonly used. One is the use case diagram and another one is the sequence diagram. Next, mathematical specifications. See, these are notations which are based on some mathematical concepts such as finite state machines or sets. Although these unambiguous specifications can reduce the ambiguity in a requirements document, most customers don't understand a formal specification. So they cannot check that it represents what they want and are reluctant to accept it as a system content. So this is another way of writing a system requirement but which is not much understood by all the people. Okay? Like if you want to represent some of the finite state diagrams or okay. We'll come back to natural language specification only. So I told that here you are writing the requirements in your natural language. Natural language has been used to write requirements for software since the beginning of the software engineering. Since the beginning of the software engineering, we are specifying the requirements in natural language. It is expressive. So, thing is you can express in your own words and it will be meaningful and universal and it will be understood. It is also potentially vague, unclear, ambiguous, and its meaning depends on the background of the reader. So, thing is sometimes it might be unclear. So, because it is the perception of the reader, because he has defined the requirements. Now, someone has defined the requirements, and for the it depends on the reader to understand, to take it up. As a result, there have been many proposals for alternative ways to write requirements. So, although the requirements are written in natural language, sometimes the reader finds it unclear or it might be ambiguous. So, might be having some different meaning. all depends on the reader. So that's why this alternative way for writing the requirements was proposed. That's why. So, however, none of these have been widely adopted. Now, you have seen the different ways of writing the requirements, but none of these have been widely adopted, and still we are continuing this one, natural language specification. So, it is the most widely used way of specifying system and software requirements. Clear? So natural language is still being used to write the requirements in an expressive way. Now we'll see the guidelines to be followed in writing natural requirements. So there are different ways of writing the requirements, but we are focusing on natural language in that one. So because all the requirements are still being written in natural language. First guideline we'll see while writing how to write a natural language requirements. Invent a standard format and ensure that all requirement definitions adhere to that format. So better you invent is keep a standard format and make sure that all the whatever requirements you are defining will be following that format. Standardizing the format makes omissions less likely and requirements easier to check. So if you keep the format standard, then what happens? There are less chances of errors and it helps you to easily check the requirement. Second one, use language consistently to distinguish between mandatory and desirable requirements. So you have, whenever you're using natural language, you need to see that there is proper distinction between mandatory and desirable requirements. The word mandatory we use, another word desirable. Mandatory requirements are requirements that the system must support. So mandatory requirements are requirements that your system must support and usually written using shall. We use the verb shall. Desirable requirements are not essential and are written using should. So in this way you have to write. Okay. Then use text highlighting. Text highlighting. Highlighting the text, any particular text in the requirements document. You can either use bold, you can make it as bold or italics or put a color. So mainly you will get to know some of the key features of the requirement. Do not assume that readers understand technical software engineering language. So always you will be, obviously you have to use some technical terms in your document. So but one thing you keep, see, a reader may not be belonging to the software background. He might be belonging to the medical background and he wants to use that system. You need to see that the reader should understand the technical terms. So you have to use some easier words, I can tell. So it is easy for words like architecture and module to be misunderstood. Now some terms will be misunderstood also. Architecture and module. So avoid such one. Avoid the use of abbreviations, acronyms. Sixth one, try to associate a rationale with each user requirement. So rationale is something that which will explain why that requirement has been included. Why that requirement has been included. Clear? Now we have one simple example for the requirements of insulin pump automated system. It's written here 3.2. The system shall measure the blood sugar and deliver insulin if required every 10 minutes. Okay. The system shall measure the blood sugar and deliver the insulin if required every 10 minutes. Okay. 3.6. See how the system shall run a self-test routine every minute with the conditions to be tested and the associated actions defined in table 1. So this is written in natural language only. First one tells that the system should measure the blood sugar level and should be able to deliver, see, shall, the system shall, so that is mandatory requirement. The system shall measure the blood sugar and should deliver insulin for every 10 minutes. The system shall run a self-test routine every minute with the conditions to be tested and the associated actions of the day. So, this is the way of specifying the requirement. Next, structured specifications. Structured specifications. So again, structured specifications, we are writing the requirements in natural language, but in a structured way. So what it is? Way of writing system requirements where the freedom of the requirements writer is limited. So those who are writing the requirements, the freedom given to them is limited, and all requirements, that means that he cannot write in his own language. Can use natural language, but it should be used in a standard way. So all requirements are written in a standard way. So what is that? So structured language notations, they will be using some templates, standard templates. So you have to use those standard templates in order to specify the requirements. Now, when a standard form is used for specifying functional requirements, the following information should be included. What is the standard form? Suppose you want to specify functional requirement, then what is the standard form? First one, a description of the function or entity being specified. So you have to describe a particular functionality or entity which has been specified. So you have to describe it. Second one, a description of its inputs. So first thing is you describe the functionality first. Second one, a description of its inputs and where these come from. So second point tells that you have to specify the inputs given to the system and you have to tell what is the source for these inputs. Third one, a description of its outputs and where these go to. So third point, you have to specify what are the outputs. What are the outputs? So where these outputs will be finally sent. That is important. Okay. So that is the third point. Next, fourth one. Here you have to provide the information needed for the computation or other entities in the system that are used. Fifth point, a description of the action to be taken. So what action you need to take? Okay. So you have to provide the description of the action to be taken. Sixth one, if a functional approach is used, a precondition setting out what must be true before the function is called. So suppose you are using a functional approach, imagine, then you have to set a precondition. What is that? You have to tell before the function is called what value you must set to true. And then post condition also you can specify, that is after the function is being called, what value you have to set to true. Clear? Now, seventh one is a description of the side effects. What all are the side effects of that? After performing the action, what are the side effects that you need to specify? So, we have an example, okay now. Structured specification of a requirement for an insulin pump. This is the standard format. So, you can see title Insulin Pump Control Software SRS Software Requirement Specification 3.3.2. So first one you have to tell the function. I have told you a description of the function or entity being specified. So you have to first describe the function. What is the function now? You have to compute the insulin dose. Compute the insulin dose. Now description. You have to give a description of its inputs. Computes the dose of insulin to be delivered when the current, you have to give the description of the functionality. Na? So computes the dose of insulin to be delivered when the current measured sugar level is in the safe zone between 3 and 7 units. So what is the description here? This function mainly used to compute the dose of insulin that you need to deliver it to the diabetes patient. So when you have to deliver it, when the current measured sugar level is in the safe zone between 3 and 7 units. Between 3 and 7 units. Inputs. Let me see what inputs are given. Current sugar reading, that is R2. Okay. The previous two readings will be R0 and R1. So we are giving the current sugar reading R2. The previous two readings R0 and R1. Source. From where these readings you have got? From the sensor, isn't it? So current sugar reading from sensor. Other readings from memory. So current sugar reading you are getting that from the sensor embedded in the patient's body. So that is, and other two readings where you have got it is stored in the memory. Stored in the memory. Now outputs. What is that? Comp dose. Comp dose function will compute the dose of insulin. So it will deliver it. The dose in insulin to be delivered. Destination where? Main control. Action. Now we are describing the sequence of activities here. Or the action. Comp dose is 0 if the sugar level is stable or falling, or if the level is increasing but the rate of increase is decreasing. If the level of comp dose is 0, it's no need to give the insulin. If the sugar level is stable or falling, or if the level is increasing but the rate of increase is decreasing, means it's okay. If the level is increasing and the rate of increase is also increasing, then you have to compute the comp dose. That is computed by dividing the difference between the current sugar level and the previous level by 4. Current sugar level R2, previous means R1. R2 minus R1 divided by 4 and rounding the result, round the result value. If the result is rounded to 0, then comp dose is set to the minimum dose that can be delivered. So if the result is rounded to 0, then comp dose is set to the minimum dose that can be delivered. Now requirements. So I've told that what are the requirements? 2 previous readings you need so that the rate of change of sugar level can be computed. 2 previous readings you require so that the rate of change of the sugar level can be computed. Precondition. Now what is the precondition? I told that before the function is called, what precondition you have to take and what post condition. Precondition, the insulin reservoir contains at least the maximum allowed single dose of insulin. Okay, and post condition is R0 will be replaced by R1, then R1 is replaced by R2. It goes on like that. Side effects, none. Thank you.